Hello. I trust that you've collected your observational data now and you are facing the task of developing some statistics to describe the data. And so this is the appropriate time to talk about descriptive statistics. I'm going to briefly talk about frequencies and frequency tables as well as bar graphs, and I think this section will be most relevant to what you need in terms of this first lab. I will go over measures of central tendency, and then another issue that is of great relevance to this lab is the estimation of Interrater reliability. Let's back up for a second and remind ourselves of scales of measurement. There are 4 different scales of measurement. Nominal, where you are dealing with categories with no order to them. Ordinal, where at least your values take some sort of order, like low, medium, high. Interval data, where you are dealing with data that has the assumption of equal intervals between numbers, such as temperature, IQ, that sort of thing, golf scores. And ratio data, where you have both ordered categories, you have equal intervals between them, and you have an absolute zero. Now, for the naturalistic observation lab, I expect that most of you are dealing with either nominal data, something is present or not present in a particular interaction, although you may be dealing with others. The use of frequencies is highly appropriate for nominal and ordinal data, and that's why we're going to spend some time on them. So here we go. Frequencies. So what is a frequency distribution? It's a way of organizing data by showing the categories that make up a scale of measurement. You might have a scale that just has 2 categories, yes or no. You might have a scale that has 3 categories, small, medium, or large, or blue, yellow, or red. A frequency distribution also has what's known as the frequency, or a little f, showing the number of scores in each category, and then this can be expressed either as a table or a graph. Notice that in the frequency distributions, you either have data that is ordered or not. Here's the most basic frequency distribution. On the left column under X, that represents score. That represents the categories in a particular variable. In this case, we have a variable that ranges from 1 to 5. We have in the F column the frequency in which we observed that variable at its various levels. So in this case, we observed, starting from the bottom, we observed a value of 1 only once. We observed 3 values of 2, 3 values of 3, 2 values of 4, and 1 value of 5. So again, the categories in the variable are on the left column. Notice if we then sum the column F, we'll get 10, and if we divide each row in F by that total, 10, we can estimate a proportion. So if we only had 1 5 out of 10 scores, that would represent 0.10, or 10% of the scores were a 5. That's pretty straightforward. Here's another example. Each year, a college gives away t-shirts to new students during freshman orientation. They get to pick the t-shirts they want. We need a frequency distribution table based on last year's orders. And you see in the lower left last year's orders. We had sizes small, medium, large, extra large, and extra, extra large. And we had a frequency, so we gave away 27 smalls, we gave away 48 mediums, likewise 120 extra larges, and 39 extra extra larges. Now let's make a frequency table out of those data. Notice a couple of things. First of all, I've taken the categories in size and reordered them a little bit so that the largest is on top and small is on the bottom. I added up the frequency of t-shirts, so it turns out that we had 370 t-shirts in all, and I've divided the frequency in each row by that total. So the most t-shirts, large is the most popular t-shirt size, and notice that 136 t-shirts represented 36.7% of the total. Keep in mind, if you have a variable that consists of something being present or absent, say a polite gesture or not a polite gesture, or different polite gestures, then you may not have really an order to your table. Now let's talk for a moment about graphing things. An alternative to providing a frequency table is to provide a graph. And the first type of graph I'd like you to become aware of is the frequency distribution histogram, or it's typically called a histogram. Now let's assume for a minute, let me see if my pointer works, let's assume for a minute that you have a set of scores ranging from 1 to 5, and that you had a frequency of, you had 2 number 5s, 3 4s, 4 3s, 2 2s, and 1 1. Or that's a total of 5, 9, 11. That's a total of 12 scores. You could build a frequency distribution table out of these data, but you could also graph it. And because these categories have an order to them, 1, 2, 3, 4, 5, you can graph them in a histogram format. Notice that each category on the x-axis refers to one of these categories here, and notice that the frequency is represented by the y-axis. So for number 3, I had 4 number 3s. You can tell that from the bar, and you can also tell that here from the table. What's nice about a frequency distribution histogram is that you can instantly get a sense of which scores occurred more frequently than others. An alternative to a frequency histogram is what's known as a dot plot. And I find these quite useful sometimes for very quickly seeing the shape of a distribution. I don't know that you need to use these for your lab, but I just wanted to make you aware of it. The bar graph is going to be the go-to graph when you have categorical data. Again, in the histogram we had categories that ran from 1 to 5. They were ordered. Here in this bar graph we have 3 different categories of this variable, A, B, or C, that may not be in any order, and the easiest thing to do, especially since it's personality type, the easiest thing to do is to simply do a bar graph again with the frequency in the y-axis. Notice here that I have more of personality type C. I have 20 of those versus 5 of B and 10 of A. So this may be the type of graph you'll be using the most. You might have a yes or no, something was present or absent, or say number of compliances with a request. You can also have the same type of layout for 2 variables. By the way, this presentation is also on the Angel site. You can have a grouped frequency table, and you have a group frequency table when you have more than 10 possible values that a variable can take. In this case, you should use a very narrow, a very consistent and simple number for the width of your interval. You'll see what I mean in a second. And the bottom score in an interval should be a multiple of the width of the interval. Let me show you. Say, for example, I have quiz grades that range from 1 to 20. Now I could create a table, a frequency distribution table with one number for each category, but that would be a 20. Then I'd have a 20, 19, 18, 17, 16, 15, 14, all the way down. Instead, what I've done is I've grouped the levels of the variable into 4 categories. Actually that's wrong. 1 to 5, that should be 1 to 5, 6 to 10, 11 to 15, and 16 to 20. And then I have the frequency of occurrence within these categories. And with that frequency, then I can get also a percentage. Now these interval widths are 5, from 16 to 20, from 11 to 15, and 6 to 10. And as I mentioned in the previous slide, I should be able to divide my score by these intervals. Measures of central tendency. I don't know if you will need to use these in the naturalistic observation, but now is the time to talk about them. What is the easiest way to summarize any set of data? Well, the easiest way is an average, or the mean. This would apply to interval data and certainly ratio data. Sometimes ordinal data as well. What is the mean? The mean is the average. It's the sum of all the scores divided by how many they are. So here is actually a fancy Greek way of denoting it. The mu is the Greek letter for to represent mean. This says the sum of the scores divided by the number of scores, and for a sample mean, the sum of the scores divided by the number of scores. Very straightforward. The median, on the other hand, is a different measure of central tendency. The median gives us the midpoint of scores in any distribution when they're arranged from smaller to largest. The median provides a quick way of dividing scores exactly in half. For example, I have 1, 2, 3, 4, 5 scores, a 3, a 5, an 8, a 10, and an 11. What is the median in this case? Well, the median is the middle score. In this case, the middle score is 8. When you have 2 scores in the middle, if you have an even number of scores, you take the average of the middle 2 scores. I don't think you'll need to do that for this first lab. Again, to review, the mean is the balance point of the distribution. It's not the midpoint. It's the same thing as an average. The median is the midpoint of a distribution. Both measure central tendency. Sometimes, though, we have data that are highly skewed, or data where it is inappropriate to use a mean or a median. This particularly applies to nominal data, the first type of data we had. In these cases, the mode is the appropriate way to summarize the central tendency of the data. What's great about the mode is it can be used actually with any scale of measurement. It corresponds to an actual score in the data. It's possible to have more than one mode. Here's an example. What is the most frequently found score in this distribution? So you have a distribution of scores that range from 0 to 10. And if you look carefully, you'll see the most frequently occurring score is 2. You have a frequency of 8. That means 2 appeared 8 times in this distribution, which means 2 is the mode. Here's a quick chart describing when to use the mean, median, and mode. We use a mean typically by default, but we should not use it when we have extreme score skewed distributions. I'll show you an example of one in a moment, or we're dealing with ordinal or nominal scales. Medians are very useful when we have extreme scores, skewed distributions, or ordinal scales. We use medians quite a bit when we deal with household data and household income data and real estate price data. Both those types of variables tend to be highly skewed, and median is often used in preference to mean. Finally, we use the mode when we are dealing with nominal scales or discrete variables. Oh, I said I'd show you skewed distributions. Here's an example of a distribution that's skewed in the left here. We see a distribution that's skewed positively. That is, it's skewed to the right. Notice here the mode, the most frequently occurring score, is at the top. The mean is actually the most affected by the skew of distribution, and a median a little less so. On the right here we have a negative skew because the tail of the skew is to the left or in a negative direction. Here again we have the mode, which is the most frequently found point in the distribution. We have the median, which is going to represent the midpoint of the distribution. Half the scores are above and below. And then we have the mean, which tends to be pulled in the direction of the skew. I'd finally like to talk about Interrater reliability. You have been asked to calculate this in your naturalistic observation. Here's the formula we reviewed in class. The Interrater reliability is the number of agreements when you're viewing something. Any variable, this variable could be age, it could be number of polite gestures, it could be the time someone complies with a request. Any event, to calculate Interrater reliability for a variable, you would estimate the total number of events observed and divide that by the number of times you agree with your partner regarding the coding of the event. Here's a quick example. Let's say you and your lab partner observed 20 interactions and rated each one in terms of rudeness, whether or not someone was rude in that interaction. So you're both looking at 20 interactions, and you're both recording whether or not a person was rude in that situation. You and your partner agree on 17 interactions. That means both of you rated them either as rude or not rude, and disagreed on 3 of them. What's the Interrater reliability? Well, you had 20 interactions altogether. You agreed on 17, so that's 17 divided by 20, multiplied by 100, and your reliability is 85. This represents the end of this lecture.